Hello students, today let us learn about gears. So first of all, what is a gear? So gear is a machine element which is used to transmit motion and power between two rotating shafts by means of progressive meshing teeth. So a gear is defined as a machine element which is used to transmit motion and power between two rotating shafts by means of progressively meshing. So there are different types of gears which are used to suit various applications. For different applications, there are different gears. So there are different gears or gear types to suit various applications. So the gear drive transmits power between two shafts when their axes are parallel, intersecting, or neither parallel nor intersecting. So the gear drive transmits power between two shafts when their axes are parallel, intersecting, or neither parallel nor intersecting. So now we will discuss the different types of gears in this topic. So types of gears which are used in practice are, we will discuss the important ones, that is spur gears. Then there are helical gears. Then bevel gears, spiral gears. Then there are rake and pinion gears. Then there is worm gears, and then we will discuss about their advantages and disadvantages. So bevel gears are further divided into many types, but as we are discussing only the important type of gears, we will not get into the details of these. Okay, so first of all, about the spur gears. So as spur gears are most commonly used in practice, we will discuss about these gears in detail, and also we will discuss the terminologies of different geometry of these spur gears. So as spur gears, so we must know that spur gears are most commonly used gears. So let us discuss the terminology of spur gears. Terminology used in these gears must be learned. Now about the spur gears. So these gears are used to transmit the power and motion when the shafts are parallel to each other. So here if you draw a shaft, you can see that when the two gears are meshing each other, these two shafts, shaft 1 and shaft 2, are parallel to each other. So these are called as the spur gears. Even here, if this is one gear, so this is actually an internal gear. Okay, if you draw the shaft, you can see this is the smaller gear which is meshing inside, but even then these two shafts are parallel to each other. So spur gears are used when we have to transmit power and motion between two parallel shafts. So these gears are used to transmit the power and motion when the shaft are parallel to each other. The speed ratio lies upon 1:8. So the speed ratio of these gears lies up to 1:8. So the gearing of the two meshing teeth can be either external or it can be internal. So here you can see this is an external gearing, that is two gears are meshing externally to each other. So here this is one gear which may be a driving gear and this is the driven gear. Okay, so externally, that is the outside circle has the teeth. The gearing can be external or internal meshing. So from the second figure B, you can see one gear has teeth inside, so it is not on the outer surface but in the inner surface the teeth are made. Okay, so this is internal gearing. So these spur gears are most commonly used in machine tools and automobile gear boxes. So they are most commonly used in machine tools and automobile gearboxes. So now we will discuss the terminology or the terms which are being used in this gears. So here terminology of spur gears. The first one is the pitch circle and the pitch circle diameter. Pitch circle and pitch circle diameter. So it is an imaginary circle which can be produced by rolling action. So here you can see this is the pitch circle. So this forms the pitch circle which moves exactly at the center of the teeth. This is the pitch circle. So this is an imaginary circle which can be produced by rolling action. It is an imaginary circle which can be produced by rolling action. Then the pitch diameter is the diameter of the pitch circle. So the diameter of this circle, so if this is a circle, then this is the diameter. So the diameter of the pitch circle is the pitch circle diameter is the diameter of pitch circle. So the gear size is specified by the pitch circle diameter. Why this pitch circle diameter is important? Because it will specify the gear size. Pitch circle diameter specifies the size of the gear. Then the circular pitch is the distance of a point on the tooth to the corresponding point on the next adjacent tooth along the pitch circle. So here, if this is one point on the tooth, the adjacent tooth has this point. Okay, the same point on the adjacent tooth, next adjacent tooth along the pitch circle. So if this is the pitch circle, the points on this tooth to the corresponding point, same point on the corresponding tooth will give you the circular pitch. Circular pitch is distance of a point on a tooth to the corresponding point on the next adjacent tooth along the pitch circle. So how do we write? This formula is pitch circle or circular pitch is P D1 divided by T1 is equals to P D2 divided by T2. So D1 is the diameter of the first gear, D2 is the diameter of the second gear, T1 and T2 are number of teeth on the first gear and the second gear respectively, and this is the pitch of these two gears. So where T represents number of teeth, or we can write it as D1 by D2 is equals to T1 by T2, where D1 and D2 are two different pitch diameters and T1 and T2 are number of teeth on the gear on those diameters. Then there is diametral pitch. So it is defined as the ratio of number of teeth to the pitch circle diameter. It is defined as the ratio of number of teeth to pitch circle diameter. So that is PD is equals to T by D, that is number of teeth, and this is the pitch circle diameter. So from this equation we can write it as pitch circle diameter into diametral pitch is equals to the pitch of the circle. Then there is module. So what is the module of a gear? It is the ratio of pitch circle diameter in mm to the number of teeth. So it is, so you will have to remember this formula for solving the problems. So what is a module? It is the ratio of pitch circle diameter in mm, in millimeter, to the number of teeth. So that is module small m is equals to d by t, or we can write it as PC, that is pitch circle diameter by the pitch, or we can write it as PC, that is pitch circle diameter is equals to pitch into module. Then we will discuss about addendum and addendum circle. So addendum can be defined as the radial distance of the tooth from the pitch circle to the top of the tooth. So here you can see this is addendum, which is A. A is the addendum which is given here. So this is the radial distance of the tooth. So from the center of the tooth to the topmost end of the tooth, whatever the distance is present, that is the radial distance, is called as the addendum. So addendum is the radial distance of the tooth from pitch circle. Pitch circle passes through the center of the tooth itself. Okay, so from this pitch circle to the topmost end of the tooth, to the top of the tooth. Then what is addendum circle? Addendum circle is the circle passing through the top of the teeth, and it is concentric to the pitch circle. So here you can see the addendum circle. This is the addendum circle. It is passing through the top of the teeth and it is concentric. It has the same center as that of the pitch circle. So addendum circle is the circle passing through the top of the teeth and it is concentric. It has the same center. Con means common center to the pitch circle. Then the next term is the dedendum and dedendum circle. So dedendum is the radial distance of the tooth from the pitch circle to the bottom of the tooth. So here you can see B is mentioned here. So if this is the pitch circle and this is the bottom of the tooth, so the end of the tooth, so this is mentioned as B, which is the dedendum. So from the pitch circle to the bottom of the tooth, whatever the radial distance is present is called as the dedendum. So dedendum is the radial distance of the tooth from the pitch circle to the bottom of the tooth. Then what is dedendum circle? Dedendum circle is the circle which is passing through the bottom of the tooth and it is also concentric to the pitch circle. So this circle which is passing through the bottom of the tooth. So this circle is the dedendum circle. And it is concentric to the pitch circle. It has a common center with the pitch circle. Dedendum circle is the circle passing through the bottom of the tooth and is concentric to pitch circle. Okay. Then what is the width of the tooth space? Width of tooth space. So it is the length of an arch between two adjacent teeth at the pitch circle. So it is the length of the arch formed between two adjacent teeth on the pitch circle. So if this is the pitch circle, this is the length of the arch which is formed between two teeth which are adjacent to each other. So it is the length of an arch or arc between two adjacent teeth at pitch circle. Then what is tooth thickness? So tooth thickness is the width of the tooth measured along the pitch circle. So along the pitch circle, the width of the tooth, so this portion, the width of this tooth along the pitch circle is the tooth thickness. So this portion, let me highlight it. So this portion is the tooth thickness which is present on the pitch circle. The width of tooth measured along the pitch circle. So this is the tooth thickness. So here you can see it is mentioned as C here. So you can see it here, tooth thickness. So the difference between the tooth space and tooth thickness is known as backlash. The difference between tooth space and tooth thickness is known as backlash. Okay. Then what is the face of the tooth? Face of tooth. So face of tooth is the surface of the tooth above pitch surface, and face width is the width of the tooth face measured parallel to the gear axis. So face of the tooth is the surface of the tooth above the pitch surface. So above this pitch surface, whatever the surface of the tooth is measured is the face of the tooth, and face width, which is mentioned here, is the width of the tooth face which is measured parallel to the gear axis. So if you extend this line, you can see if this is the gear axis, these two are parallel to each other. So it is the surface of tooth above the pitch surface, and face width is the width of tooth face measured parallel to gear axis. Then what is a profile? So all these are the terms which we are using to describe the gear, and here specifically the spur gear. So it is a curve which is formed by the face and the flank of the tooth. So profile, it is the curve which is formed by the face and flank of the tooth. So it can be involute or cycloid. So this profile can be, it can be involute or it can be cycloid. Okay, so if this is the face of the tooth, if this is the face of the tooth and this is the flank, so whatever the curve is formed between these two is called as the profile. So here you can see it can be involute or it can be cycloid. Now what is the flank of the tooth? So flank is the surface of the tooth below the pitch surface. It is the surface of the tooth below the pitch surface. Then path of contact. Path of contact is the path which is traced by the contact point of two teeth from the beginning to the end of the engagement. So here you can see two teeth are engaging with each other. So it is the path which is traced. Okay, so the path which is traced by the contact points of the teeth. So wherever the teeth are contacting, there is a path which is traced from the beginning to the end of the engagement. So this is the path of contact. So it is the path traced by the contact point of two teeth from the beginning to the end of engagement. So this is the terminology of spur gears, which are most commonly used type of gears. So the next type of gears which we are going to learn is the helical gears. Helical gears are also type of spur gears. So in this gear also, that is in helical gears also, the shafts are parallel to each other. In this gears also, the shafts are parallel to each other, except that the teeth are cut in the form of helix. So here the teeth are cut in the form of helix. So that is why they are named as helical gears. So the mating gears will have some helix angle, but one gear has a right-handed helix while the other gear has a left-handed helix. So the mating gears have same helix angle. So the helix angle will be same between the two mating gears. So here you can see the gears are mating here, but they are not cut in involute form, but they will be cut at an angle, that is at a helix. They are in the shape of a helix. That is why they will form same helical angle, but one gear will have right-handed helix while the other gear has left-handed helix. So the speed ratio of these type of gears, so here you can see these are helical gears. Okay. The speed ratio of these helical gears is up to 1:12. So a speed ratio of 1:12 can be obtained by these helical gears. The advantage of this gear is that their engagement is shock free and the operation is silent. So when they are engaging with each other, they do not produce any shocks. That is, the engagement is shock free and there is no noise also. The operation is silent. The advantage of this gearing is that their engagement is shock free and the operation is silent. So they are generally used in power transmission system of automobiles. So helical gears are used in power transmission system in automobiles. So these type of gears, that is the helical gears, transfer large loads at higher speeds and also they are very smooth when compared with spur gears. So they transfer large loads at high speeds, that is higher speed, and very smoothly when compared to spur gears. So the disadvantage of these helical gears is that they have high manufacturing cost and they are difficult to manufacture, and also they impose radial as well as axial thrust on the shaft. The disadvantage of these gears is that they are high manufacturing cost, difficult to manufacture, and they impose radial as well as axial thrust on the shaft. So this is all about the helical gears.